Okay, time to get some work done. It's almost 8 o'clock. It's getting cold. Time to work. Alright, so I got my reamers came in for doing this job, but we'll have to make that work yet. So I'm working on some twin cam piece of crap that everybody wants me to work on. I guess they want MH now, but oh well, we'll deal with these. So this one here, we just got done boring it out here a couple days ago, whatever it was, for the 117 kit, which is the cylinder kit right here. And we had to check piston heights to make sure the pistons all work. So now when you're doing an S&S piston, these here, and you put the motor together, you have a not zero deck like S&S claims it is. So get my tripod going here. So the way you check this stuff is you have to have a gasket, because that's what they use. Right here, paper, heavy duty. Put that on your cylinder. You got a piston. This is the S&S piston. And the S&S cylinder. And an S&S gasket too. There you go. So then you go up and down like this with your piston, and you see if it hits your scale. And if it doesn't hit your scale, you know the piston's below the deck. So S&S claims they run a zero deck. Zero deck means that when the piston is all the way up, it is flush with the cylinder. So there's all the way up right there, and that is not flush because the piston is below the surface. So now the way you find out how far below the surface it is you put something between your flat surface here and your measuring stick here. So usually what you use is something called either another scale or a feeler gauge, or whatever you know the thickness of. You can use paper like this. You can stick a piece of paper in there, run that across like that, and then move the motor up and down. If you feel something hit the bottom of your scale here, you know it's hit. When it doesn't feel any pressure against it, it doesn't hit. You can actually feel it pretty good. Don't try to look at it, just feel it. So you take two hands, you go up and down. So you basically go like this with it here. Now you don't do it front to rear, you do it side to side, because side to side the piston rotates like this and like this. Like this means these two surfaces are not even. Like this, the rod doesn't go side to side, it goes up and down. So you go like this with this, and you go back and forth like this. And if you look at the scale, it's popping up in the arrow on this side a little bit, because this is thicker than 6/1000. It's probably about 15/1000. Ooh, pretty good guess. 14. So, if you measure over here on this side, it's 7/1000. So if you just put that piece there only, like this, and do the same thing, I can still feel it hitting because this is 7.5 thou and we're 6 is our clearance. Let's see, you can feel it. Alright, so we know we're 6 thou deck. You want to run a minimum of 30 thou clearance between the piston and your head. Otherwise you're going to have some issues. Even 30 is pretty tight. After you do a few thousand miles, the piston will get a little loose, it'll start hitting the head. So it's better to be at 35, but 30 is your minimum. So what we're going to do is we're going to put some thinner gaskets in there. Here's this is a 22 thou thick one. You can get the Climatic makes these in all kinds of different thicknesses when you special order, so whatever you need. They also make base gaskets down here that are thinner than the 20 thou paper one. They make metal ones that are thinner. So you can mix and match all kinds of different dimensions, top or bottom. The end result is the piston has to be zero decks, and your head gasket will be your clearance, is usually how you do it. But you don't have to. You can have a little bit of a pop-up of the piston, just have a thicker gasket, it does the same thing. So if you have a 10 thou pop-up, you want 30 thou clearance, you got to have a 40 thou gasket. If you got 20 thou up, you need a 60 thou gasket. Or not 60, 50 thou. So as long as you come up with that 30. And like I said, you can also take the base gasket and move it up and down a little bit too. So the end result is that's how you do it. Now the other piston that we were playing with was thicker than this, had a higher compression height, which means the deck of the piston's higher up, and it didn't work. It was hitting. So that's how you figure that stuff out. Alright, so this motor here we're pretty well good on for figuring out clearances. So I know what I'm going to do now. So that makes that simple. Now the next problem is you got to replace the main bearings in there. So main bearings get bad, they get tight or they get loose. Oop, don't forget the gasket. Don't want to tear your gasket, so put it back away so you don't tear it. It'd be a bad thing. You keep everything in the box over here where it's nice and safe, you don't get damage. So the main bearings in here have to be replaced because they're too tight. This one here is bonded up pretty heavily, and it screws and squeaks when you rotate it. So not today. No, not gonna squeak today. Yesterday it was squeaking. So anyway, it was tight. It's still tight. I had to push the case in pretty hard. I had to almost press it in there to make it go with the roller bearings. They're so tight. This side over here, they were snug, but they had a little bit of clearance in them, so they're kind of runnable. It's probably how Harley sets them up. But anyway, this one here, we're going to put 2 new main bearings in it, and then that should be good to go. You know, everybody, the customers can finish motors up, other shops, whoever's doing the motor work, they can assemble it from here. Twin cams are pretty much a throwaway motor. Anybody can put them together because it's just slip and slide. There's no machining to be done. Once you get the new bearings pressed in and your machining done, anybody can put them together. They're simple. That's why Harley went to these. They're cheap. Cheap throwaway motors. No scale required. Okay, so we'll deal with that. So now I got another one I got to work on. It's floating around here somewhere. We're going to do some boring. So I think that one's over here. Yeah, there it is. Pink monster. There it is. Now this one here had rat turds in it. So they were full of dirt. You can see there's all the corrosion in here. It's all rusty. And it's all corroded from water. It's been sitting for a long time. The bearings do not move. They're rusted in. So you're not supposed to leave your motor sitting out. So there you go. You can see everything's kind of white. It's all full of corrosion. Like that, it comes on your fingers. So anyway, this has to be wiped out at some point, but we'll let customers worry about this stuff. Also, these are powder coated, so all the powder coating has to be taken off surfaces that matter. You know, surface that matters, anything that's got a flat machine surface. Like you get your cylinder base right here. There's powder coat right there. That has to come off for this to seal for the gasket to seal. If you don't, it won't work. Okay, so to do this motor, I got to pull these studs out of here. These all have to come out, and these dowel pins right here have to come out right here because I have to be able to put on this plate right here, and I need to be flat. So I pretty much sacrifice these 2 dowel pins every time I do a job like this because they have to go away. And here's more of that overspray from the powder coat, which means I have to make these flat too because I don't want any of these surfaces to be uneven because I got to bore these out for bigger cylinders. So this one's going to be going to a 110 or 113 cylinder. I don't know which one it is. I have to go measure the cylinder and figure it out. So anyway, that's all what we have to do here. When all this stuff has got cosmetics crap done to it, it just makes it harder. See, this one has powder coat on a dowel pin, so the cylinder might not even go down on that one. Hard to tell. All right, so let me get these where I can get this apart. Get some tools. I'll be back.